Hello, my humble learners. We are now on the trigonometric subject that we have in mathematics learning. And the first part of it is the angles and their measures of a certain problem. So hold on, take your deep breath, and enjoy watching the video. Hope you like this video. If you like this, just share, follow, and like, and give this link to other learners also that needs to that wants to learn more in mathematics. Okay, so as far as we know that this is the first discussion in the trigonometry that deals with angles and their measures. So if we want to know further about what is this trigonometry means, trigonometry, it deals with the measurement of the triangle, meaning to say that trigo means trigonometry. From the word trigo means triangle, metros is measurement, so we're dealing with the measurement of a certain triangle that we have. So what this trigonometry is all about, it deals with the relationship among the sides and the certain angle of a given triangle that we have, that used in the development of this in our field of astronomy, navigation, and surveying. So this comes from the development of that calculus way back in the 17th century through physical sciences. A different perspective arose as it goes through that certain century that we have. One that viewed the classic trigonometric relationship as functions with a different set of real numbers as their domain. So this trigonometry is merely applied through the expansion of physical phenomena involving rotations and vibrations, including sound waves, light rays, planetary orbits, vibrating springs, pendulums, and orbits of atomic particles. So this is how we deal with trigonometry. So we are going to discuss this one part little by little, step by step. So we are going to start first about the angles and their measurement, because this is very much important to deal with this part of trigonometry. So as we explore the perspective of the angles and the measurement, so we are going to understand first what this angle. So the angle is determined by rotating a ray about its end point. So the starting point that we have is what you call this as the initial side, and starting point is what you call it the initial side. Then the ending point position is the terminal side, representing with the arrow ray. So in this manner, we're going to understand the concept of the two given side, the terminal side and the initial side. Then there is an angle that form from that two certain rays. So therefore, that would be the very much the mere fact that we're going to understand in dealing this discussion. Now, so this is now the standard position in the how to deal with the terminal side and the initial side. So as you can see here, that the initial side that we have is this portion here. This one is our initial side, that one there, this one, and then the terminal side. Then this is now the angle that is formed on the two given side. Now, since this is the standard form, so as you notice, it's just like a Cartesian plane. The vertex here is at the origin. given the initial side starting from the x-axis, the right portion of the x-axis. So this is the initial side with the given angle 0, 360. I'll explain this one little by little. Why is it that 0 degree and 360 degree comes in? So now take note that if we're going to rotate this one, this is what we intended for the standard positioning, because there is a big impact for the angle referring to this manner. So as far as we know that this one is 90 degree, so this is the upper portion is the 90, the left side portion of the standard position is 180, the below part is the 270, and as it goes back 360. So meaning to say that since this is the right side portion is our initial side, so therefore if we're going to rotate further so it will go to 90 degree, then 180 degree, then to 70 degree, and it formed now the complete revolution, and that is 360 degrees. So as you notice there that the positioning is very much important, because as you can see the angle there are both positive. So it means that the rotation must be in the counterclockwise direction. What is counterclockwise direction? So we're going to understand the angle by the way for that as we go through. So we still the same that we're going to understand the quadrants that we have. Here is the quadrant 1. Here is our quadrant 2. Here is our quadrant 3. These are the region in the Cartesian plane that we have. Now, as I said a while ago, when we generate a certain angle, when we work with a counterclockwise rotation, we come up with the positive angles. So as you can see there, the 90, the 180, the 270, the 360 are both positive. Then as I rotate there, the angle is going from the initial, then that one, from the initial part, then going that one, going to that part. So that one is the counterclockwise direction. Whereas when we talk about negative angles, that it generated a clockwise rotation. So therefore, from the initial, then going to that portion there in our standard position, rotating this positioning, this action, it means clockwise. So the angle that can be formed is a negative angles. So we also have to understand how the negative angles are very much important in the coordinating graph or in our Cartesian plane for the standard position. So here it goes in the negative angles. So now from the initial side given that we have, so if we're going to make this one, so we have here negative 45, considering this one is a negative 45 angle. The angle here is 45 degree. Since the direction is in the clockwise direction, so it became negative 45. So now if we're going to have this portion here, so from the initial, then rotating here, going to this part, then this one is equivalent to negative 90 degrees. Then the lower part, this is negative 90. The left side part, the standard position is 180. Going up, it measures now negative 270, and then it goes back to the initial side. Then that one is negative 360, and so on and so forth. Then take note that even if clockwise or counterclockwise, the certain angle that we have is, we can perform infinitely many angles that can be formed, whether in the clockwise or in the counterclockwise position. Okay, so in the angles that we have, as you notice that when we refer Greek alphabet, the small lower script Greek alphabet, this one, or any other Greek alphabet, that one is represented by an angle of a certain triangle. So we have here symbol alpha, beta, or theta. Then if we can encounter the Greek alphabet or Greek letters in the Greek alphabet, so that one is represented by the angle. Or another way around in the traditional one, so we have here a single letter which is represented also that our angle. So we name that one as angle A, angle B, angle C by their vertices that we have. So what does it mean about this coterminal side? It is an angle that can be formed from the initial side and terminal side. So here in this example, as you notice there, that this one is really our terminal side, initial side, that one there, and then then this one is our terminal side. Initial side is always start with the right side of the x-axis. Take note with that. Right side of the x-axis is our initial side. Then it ends with the terminal side, the side that can be formed out connecting to the initial side. So this one here is rotating counterclockwise direction. It represented by the angle alpha. Then this one is the clockwise direction. Then this is represented by alpha. Take the beta rather. So take note that the angle here, since it performed here clockwise direction, the angle that can be formed must be negative, whereas here in the counterclockwise direction, this is now positive angle. Okay. Another thing is we have here another example. So the initial side, as I said, always starts from the x-axis, the right side of the x-axis. Then this one here. So the alpha here is the angle that can be formed interior of that, and then beta here is rotating this one, then it ends here. Still the same. Alpha here, the beta here. So beta, the alpha and the beta, the alpha value is the same as the beta value angle. Still here, it's still the same here, that the alpha and the beta is still the same, but then the first angle is positive, namely angle alpha, whereas here the beta is negative, but they have both the same angle. So they have the same initial sides. Since they have the same initial sides and terminal sides, so therefore we can now have the coterminal angles. So coterminal angles having the same initial and terminal sides. So in this case, determine two angles of the 60-degree angle. The one is positive and the other one is negative. So you have here 360 plus 360 is equal to 420 degrees, because we have here initial side, terminal side, and then if we're going to have that, this is the reference angle or the starting angle, base angle that we have. And then if we're going to have that one, since we started here in the initial side, then rotating here and then it ends it here. Okay, so we come up with 60 plus 360, because 360 is one complete revolution, one rotation that we have. So we come up now here 420 degrees. And then, as I said, there also another set of another value which is negative, but then they have the same value. So we have here, starting here with the initial side, then clockwise direction, and it ends here. So we have here negative 90, negative 180, negative 270, and since this is 60, so we have here 30, So this is now negative 30 degrees. So we have now negative 300. Or in such a way, 60 minus 360 is equal to negative 300 degrees. So we could now have, since the inner portion is 60, so what is remaining on the outer portion is 300. Then take note that it seems that our direction or our rotation is in the clockwise direction, so the answer must be negative 300 instead of become 300 or positive 300 degrees. Okay, we're going to give some coterminal angles of a 30 degree angle. So we have now here our bases. So initial 30 is between 80 to 90. So this is 30 degrees. So if we're going to rotate further, so one complete revolution, so we have here 30 plus 360, so we come up now 390 degrees. So in the counterclockwise direction, whereas from here going to that part, so we have 30 minus 360, so we could now have 330 degrees for the negative. But then take note that two coterminal angles, so it doesn't mean clockwise or counterclockwise. It could be it could be same as this. It's okay. Like this one. If we're going to extend further about this one, another set of rotation. So 330 degrees plus 360 first rotation and another set of rotation, we come up with 720 plus 30, and that is 750 degrees. Because it based from the objective that we have, we're just only give two coterminal angles. Just choose whether of the three, whether among the three, it's still the same. Okay, that one. So give a coterminal angle one that is positive. So one that is positive. So meaning to say, we're going to give our answer, our work to be in the counterclockwise position or rotation. Then the other one is the negative one, which is we can perform the negative value, or we can get the negative value through the negative direction by means of clockwise direction. So the 230 degrees is between, yes, that's correct, it's between let's say this is the 230 degrees between 180 and 270. So since we wanted to have another set of positive, so we are going to rotate another rotation. So we have here 230 degrees. This is 230. Plus 360, and we come up with how much? What is the sum of this? So we have here 590 degrees. Okay, that's the positive valued one. How about in the negative? So we are going to work with the counterclockwise direction. So in the counterclockwise direction, we have here from here going that part. So if this is 90, this is 180, to make it 230, so we have here 50. So this is now 40 because we have here 90 degrees here as the sum for the complementary. So therefore we have now 90 plus 40, or just to say negative 90, since the direction is clockwise, and then negative 40, so we come up with negative 130 degrees as the sum. So we have that. Okay, then we are going to identify the value of the coterminal angle. First is the positive one, and one is negative. So then again, we're going to understand counterclockwise direction is for the positive, then the negative one is for the clockwise direction. Since that it is equivalent, that the given is negative 20, so we started from the initial side here, and then our terminal side here, and then we have here negative 20. So this is our negative 20 degree. So therefore we are going to rotate further. So we could now set as negative 20 as the initial or the base angle, then rotating 360 degrees, so we come up with negative 380 degrees. Then for the positive value, so from the initial going down counterclockwise direction, then we have that. And so this is 20, so therefore this is 70. So 270 plus 70, so we have here 340 degrees, because this is a 90 degree angle here, so we have here 20. The complement of 20 is 70. Complement. So we have that. Okay. So how about as we get the coterminal angle with the given 460 degree? So 460 degrees, so meaning to say we are going to draw here. So this is 360. Then we have now 460 minus 360. We have remaining value 100. This is 100. So now we have 100. So we have now the terminal side here. So if this is 90, so this is 10. Okay, so we now have 100 degrees. The complement of 40 degrees is 50, while the complement of 120, since it is here, so since we are talking about complementary, so no complement, because it should be it should be the sum of 180, and then more than one, it should be the sum of 90. Then it's since it is more than already to 90 degrees, so you cannot perform the complement of 120 degree. The complement. So how about for the supplementary angle with respect to this case? So we have here 40. So 40. So the sum must be 180. So if this is 180, so this is now the straight angle. So this is now 140. So 180 minus 40, and that is 140 degree. Whereas here, so we could now have a supplementary angle for this. The okay, excuse me. So 120, this is 120 degree. So what is remaining here, since it has a sum of 180, so what is left here is 60, because 180 minus 120 degree is equivalent to 60 degree. Okay. If we talk about the complementary coterminal angle, so therefore we now have to understand the concept of the given angle added to 360, or because the direction is counterclockwise direction, so it must be added to 360, or just we say subtracted to 360 because of the direction is clockwise direction. So the for us to be identify or to be able to get the coterminal angles, so we have angles plus or minus the 360. That's the explanation of how to deal with the coterminal angles. Whereas if you're going to find the complementary angle, is the 90 degree minus the angle given. Complementary. Then if we have supplementary angle, we need to have supplementary angle is that we're going to have 180 minus the given angle. So now let's proceed to what we call a radian measure. When we talk about radian measure, is that 1 radian is the measure of central angle theta. So with the intercepted arc, or intercepts an arc of S that is equal to in the length to the radius r of the circle. So as you can see here, so this is our central angle, that angle that can be formed from the center of a circle. So this is represented by the theta, then the arc length, intercepted arc S is represented by the arc length that we have. So take note that we are going to understand the concept of the circumference, whereas the circumference is equal to 2 pi r. So now the r that we have is c over 2 pi, because divide both sides by 2 pi, so it is cancelled now. So r now is c over 2 pi. Then take note that one complete revolution is equivalent to 2 pi radians, because the r here is equivalent to 1, so in the unit circle. So take note with that. Okay. Now, because of the circumference of a circle is equivalent to 2 pi r, it follows a central angle of one of full revolution corresponds to an arc length of 2 pi r. So as you can see here, this is the arc length represented by one complete revolution, which is represented by the 2 pi r for the value of s. So in such a way that the 2 pi radians is equal to 360 degrees, the half of it of the, since the one complete revolution is pi, so half of it is 180 pi, which is equivalent to pi radians. Then half of the pi, which is pi over 2 radians, is equivalent to 90 degrees. Let's take a look at it. Okay, so as you can see here in our unit circle, which is, we have here the radian. So as you can see, this is our initial value. So we have one complete revolution is equivalent to 2 pi radians. So half of it is our pi radians. Then half of the radian pi is equivalent to pi over 2. And then if we have added the pi to 1/2, it is equivalent to 3 pi over 2. So this is now 0. This is now 90 as far as we understand before. Then 180. Then this one is 270. Then 360 degrees. Since we have now farther, so as you can see, half of the pi over 2, which is pi over 2 divided times 1/2, which is equivalent to 1/4. So this is now the arc length here of pi over 4. So then half, since we have pi over 4, so if we're going to add the pi over 2 to pi over 4, we come up with 3 pi over 4. We have here. Then 3, we have here pi. Another, this one is pi plus pi over 4, which is equivalent to pi over 4 that we have. So we have that. So pi plus 1/4 pi is 5 pi over 4. This is now 3 over 5. 3 pi over 2. 3 pi over 2 plus 1/4, and that is 7 pi over 4. And the other one is 2 pi. So take note of that. That one and that one. Okay, more common angles that we have. So let's take a look at more common angles that are found in a, so we have now another set that we have. So as you can see, we come up with pi over, this one here is pi, this one here is equivalent to pi over 6, and this is pi over 3. So it means that we have here 90 divided by 4 and 90 divided by 3, and this is equivalent to 30, 60. This is 60 and this is 90. So it means that the unit circle from 0 to 90 or 0 to pi over 2 must be added to, so not by added, but we have divided it to 3 parts. So 1 and 2 and 3. So meaning to say that the pi over 6 or radian is equivalent to 30 degrees. Then we also have pi over 3 radian is equivalent to 60 degrees. And we have 90 is equivalent to pi over 2. Another thing is we have here, it is divided into 3 parts, not anticipating the denominator of 4. So we have here 5 over 6, 5 pi over 6 radian. So we have here 30, another set of 30, so 90 plus 30, and that is 120, which is equivalent to 2/3 pi. Then we have pi over 6 radian. then 7 pi over 6 radian, then 4 pi over 3 radian, and 5/3 pi radian. So look at the quadrants that we have there. So here is a quadrant 1, which is represented by 0 between 0 to 2 pi over 2. This one is quadrant 2 between pi over 2. The angle theta is between pi over 2 to pi. The quadrant 3 is we have between pi and 3 halves pi. Quadrant 4 is equivalent is between 3 pi between 3 pi over 2 and to 2 pi. So determine the quadrant of the terminal side of each angle. So we have here pi over 3. Pi over 3 is equivalent to first quadrant because as far as we know that what this is equivalent to 180, the pi here, so 180 divided by pi, divide by 3, so come up with 60 degrees. Then it is equivalent to between 0 to pi over 3. 7 pi over 12 is in the quadrant of let's say 7 times 180 over 12, and that is divisible by 4, divisible by 6 at 2, so we have 6. 90 divisible by 3, so we have here 30. 2 divisible by 2, 15. 2. So 7 times 15, and that is 5 carry 3, 105. So this belongs to the quadrant 2. Here we have negative, so as far as we know, as far as we understand the concept of the negative, so still the same thing that we are going to rotate it into clockwise direction. So we have here negative 2 times 180 over 6 and over 3 rather. So we have divisible by 3, we have 60, so negative 120 degrees. This belongs to quadrant 3 because accordingly when we have in the direction of clockwise direction, so from 0 to 18 to 90, from 0 to negative 90, that is equivalent to negative 270, and then it's equivalent to 270. Then the other one is negative between negative 90, the negative 9 between negative 90 to negative 180 is part of the quadrant 3. Here we have is we come up with 371 degrees. So from there, so it is equivalent to 1 to complete revolution subtracted to 360, so we come up here 11 degree, which is this one belongs to quadrant 1. Okay, okay, that's it. That's the explanation that we have in this slide. So next thing is we have determine the quadrant of the terminal side of each given angle. So we have here 2 and 4/3 pi belongs to quadrant 2 because one complete revolution, then this is quadrant 3, quadrant 3, another one, quadrant 2, quadrant 4, because in number 1 we have we come up with in such a way in number 1 in this problem 2, it is if we're going to make this one into mixed fraction, we come up with 2 and 4/5 pi. So meaning to say, we have 1 revolution, which is equivalent to 2 pi plus 4 over 5 pi, which means this 4 over 5 pi is our coterminal co-angle that we have. So this is just the same as then 4 over 5 is between 1/2 to and pi, so therefore it is equivalent to quadrant 2, whereas this negative 156 degrees is also belong to quadrant 3, because if we have counterclockwise direction, so this is negative 90 for the quadrant 0 to negative 90 for the quadrant 4, then negative 90 to 180 between negative 90 and negative 180, this belongs to quadrant 3. So since negative 156 is between negative 90 and negative 180, so this is now falls to quadrant 3. Then we have 9 pi over 8. So as you notice there, that it is the improper fraction must be interchanged to mixed fraction. So we have 1 pi plus pi over 8. This pi over 8, this pi is more than quadrant 2 added by pi over 8, which is has an equivalent value of 180 over 8, so divisible by 2, which is 490, then 90 over 4, so divisible by 2 still, so this is 45 and this is 2, so 45 over 2 or 22.5. So the 22.5 that we have must be added to pi, so it means that it's just belong to quadrant 3 betweenness of the two given part. But negative 240, it falls under negative 180 to negative this negative 240 is in the quadrant 2 because this is just between negative 180 and negative 270. Then this 100 degrees is 360 for one revolution, another 360 for another set of revolution. So we have 360 plus 360, and that is a 270, 720 rather. So 1000 minus 720, we have here 0, 8, and we have here 9, so which is 2. So our coterminal value of the angle is 280. Then since 280 it falls to quadrant 4, so 1000 degree is under quadrant 4. Okay. Coterminal angles using radians. So two angles are coterminal if they have the same initial and terminal side. So part of reordering week, as I have discussed that one late just previously. So we need to understand the concept of initial and terminal sides, because that it caters the concept of coterminal angles, the value of the coterminal angles. So that is how the coterminal angles plays in this topic. For instance, the angle 0 and 2 pi are coterminal because it has a one complete revolution. You can find the angle that is coterminal to the given angle theta by adding or subtracting 2 pi. So as you notice, based from the discussion or based from the given explanation that I have shared with you a while ago, so we come up with how to add or how to subtract further values in terms of angle or in terms of pi, as long as we have to understand the concept of the basic concept of the fraction, from improper to prop to from improper to mixed fractions, because radian is catering such fraction, the improper one. Okay, find the coterminal angle of pi over 6. Pi over 6 is just the same as 13 pi over 6. Why? Because as you can see, pi over 6 and 2 pi, which means the 2 pi here is the one complete revolution, considering this one is our pi over 6. So we have here 30 as equivalent for the angle. Then if we're going to have another coterminal, which is one complete revolution, which is 2 pi, so we have here 13 pi over 6, or 360 plus 30, and that is 390 degrees. And yes, it is equivalent to 3. So take note that the coterminal angles, as I have said just previously, it is an infinite number of coterminal angles. So we do have so many numbers that are coterminal angle based from the given for the certain angle, whether negative value or a positive value. In terms of we revolve our terminal to initial site and finding such a way of coterminal angle. So we have to get the coterminal angle of a 13 pi over 4, both positive value of it and the negative value. So as you can see that this one, if we're going to have that, so this just have an equivalent value of 3 and 1/4 pi. So which means this one having a 2 pi and 1 and 1/4 pi rotation. So we have one complete revolution, then we are going to identify where can we locate the 1 and 1/4 pi. So which means that it has an equivalent value of this one is equivalent to 5 pi over 4. So 5 pi over 4. So if we're going to locate further, this is pi, then 3 halves pi, so this 5 pi over 4 belongs. So we have here, so this is our 13 pi. This is our 13 pi over 4, and such a way that this one from here to that part is the 5 pi over 4, and then the negative, so the coterminal is 5 pi over 4 for the positive value. For the negative value one is from here to that part, so which means that we have negative pi over 2 from here, which is negative pi over 2, and another set of, or just to say another, since it is 1 pi over 4, so this is pi over 4 as we know it. So negative pi over 2 added to negative pi over 4, so we come up with negative 3 pi over 4, or just we say 5 pi over 4 subtracted to 8 pi over 4, so given that one, so this is equivalent to negative 3 over 4. Okay, another set is 5 pi over 5 pi over 5. So in this case, or in this problem, so we come up with the easy way for us to work on it is we are going to convert pi into 180. So 180 divided by 5. So we have here, let's say this one is, we have here 336. So it has an equivalent value of 36 degrees. So we have 36. So this is for the positive 36 degrees. Then if we're going to rotate that one, so 36 degrees added to 360 degrees is equivalent to 396 degrees, or just to say 2 pi plus pi over 5. So we have 10 plus 1 pi, and that is 11 pi over 5. And then for the negative valued one, so we have here from clockwise direction, so we come up with 2 pi minus pi over 5. So we have here 5, 10 minus 1 pi, and we have 9 pi over 5, the negative one. Okay, negative. So this must be negative 2 pi plus pi over 4. So 5 pi over 5, so negative 10 plus 1 all over 5. So we come up with negative 9 over 5 pi. Okay. Find the complete complement of each angle. So we have how it became pi over 10. So we have here 360, as we know the value of 2 pi is equivalent to 360. So we come up with 72 degrees. So the 72 degrees, it falls from the first quadrant, so complement. So this is 72 degrees, or just you say 2 pi over 5. So then this is another one, which is 20, no, 6. We come up with so we have 90 minus 72, and that is 18 degrees. Okay, so if we have now further discussion out of this, so since the given is in radian formation, so as far as we know, since we now understand that the value of 2 pi over 5 is between 0 to 2 plus 2 pi over 2, so therefore we have pi over 2 subtracted to let's say subtracted to 4 to identify the complement value. So 2 pi over 2 pi over 5. So get the LCD, which is 10. Then this is 10 divided by 2, which is 5, minus 2 minus 4 pi, and that is 1/10 over pi. So now we need to identify its supplement. So since this one is equivalent to 72 degree, so we have here 72 degrees. This is the terminal side, the initial side, so this is 72 degrees. So since it is supplement, so mean to say subtracted from 180 to 72. So we have now 8 108 degrees, the supplement value. So which means we are working or identifying the value of the value of its supplement. This is the supplement value that we have, so this is our 108 degrees. So but then, since as I said, this is just written into radian, so we follow the concept of radian. So this is 0, pi over 2, this is pi. So for us to know further, so we have here pi minus 2 pi over 5. So we come up with 5 as the LCD. So we have here 1. So 5 minus 2 pi, and that is 3 pi over 5. Find the complement and the supplement of complement and supplement of each angles if possible. 2/3 pi. Okay, 2/3 pi is equivalent to 360 over 3, and that is 120 degrees. So since the given terminal, this initial and terminal side is coming from the 120 degrees, so no complementary angle. Okay, but there is a supplementary of this, so this is 60. So we have 120, so pi minus 2/3 pi. So we have here is 3. So we have 3 minus 2 pi. So we have here pi over 3 as the complement, as the supplement rather. Then no complementary angle that we have. So the coterminal angles is we are going to have some point of clarification or set of analysis that we are going to, in order for us to get the angle, coterminal angle, so we come up with angle plus or subtracted or added to 2 pi. If we have to find the complementary angle, we have to subtract from pi over 2 the certain given angle. So pi over 2 minus the angle. If we're going to find the supplementary angle, so we come up with pi minus the angle. So that's the recap that we are going to understand further in knowing the supplementary angle, the complementary angle, and its coterminal angles. Take note that the coterminal angles have infinitely many number of angles. So take note also, in you convert something, that the pi, that 1 degree is equivalent to pi over 180 radian, or 1 radian is equal to 180 degree over pi. So we have now how to convert 135 into radian. So we have here as we have here we have 135 degrees times pi over 180. So if we're going to work out with that, so this is divisible by 135, 180 is divisible by 5. I will make use of the continuous division for me to be able to work out that. So 135 divided by 5, and that is 27. Here we have 36. Then still the same with divisible by 9. So we have here 3, and this is 4. So therefore this is this is now 4, 3, and this is 4. So the conversion of 135 degrees to radian is 3 pi over 4 radian. So negative 270. So we have here negative 270, then pi over 180. So we have negative 270, 180 divisible by 90. Excuse me. So this is negative 3. Then this is 2. So therefore this is negative 3 pi over 2. So we have to convert now 9 pi over 2 radians to degrees. So we have here 9 pi over 2 is equivalent to 9. As far as we know that the pi is just the same as 180. So this is divisible by 2. So this is 90. So this is now 9 times 90 is 810 degrees. Okay. 2 radians to degrees. So we have here 2 degrees. So we have 180 over pi. So we come up now as 360 over pi. So 360 over pi, and that is equivalent to 114.59 degrees, because this one is approximately the same with 3.14, 15, 16, and so on. So rounded off 3.1416. So take note that the arc length is the relationship. The arc length is the relationship between the arc length, radius, and central angle, represented by S is equal to r theta, where theta here is in the radian. If the given angle, if the given theta is in degrees, so we are going to change the convert that one into radian. Okay, radius times the angle. We have here given a circle has a radius of 4 inches. Find the length of arc intercepted by a central angle of 240 degrees. So in this case, we're going to have to convert first using this formula. S is equal to 100 r theta. So S now is equal to 4 times theta, which is 240. So 240 must be converted into radian. So 240 radian measurement. So pi over 180. So we have 240, 180. So this is divisible by 10. 24, 118, divisible by 6, 24, this is 4, then this is 3. So 4/3, excuse me, this is 4/3 pi over 3. So therefore we have here 4 pi over 3. This is the data that we have converted. So we have now 16 pi over 3 as the value, or 16.76 inches. Okay, so hope you enjoyed the discussion of angles and the measurement in terms of the trigonometry subject. So feel free to ask questions, just leave comments in the comment box icon, and hope you have to have a grateful minds in sharing this video to your classmates, to other set of learners, for them to be able to understand also as what you have understood based from this lesson. Okay, thank you guys. See you next video.